Imagine, just for a second, being asked to build an entire city. And I'm not talking about a house, not a single room, an entire city from the ground up.
Really think about it. Roads, schools, hospitals, the water systems, the electricity, transportation networks. Where do you even begin? Most of us, we'd absolutely freeze. It's a completely universal human experience. When our brains are confronted with massive, sprawling complexity, we just lock up. We get totally overwhelmed. But the people who actually build these things, well, they do something very different.
Builders divide. They don't try to solve the whole universe at once. They create pieces, chunks. And suddenly, by stepping away from the whole, the impossible becomes completely possible. So let's dive into this explainer, because what we're really unpacking today isn't just a strategy for construction. It's actually one of the most powerful ideas in human thinking, how massive problems become solvable the second they become small.
You see this everywhere, right? Whether you're starting a new business, writing a book, trying to lose weight, or learning to code, it all seems incredibly daunting at first. Why is that? Because the ordinary mind focuses on the entire mountain. But the builder mind? The builder mind deliberately restricts its view to just the very next manageable chunk. They aren't trying to carry the mountain, they're just looking for that next safe foothold.
So let's look at the science of chunking to see how we can reduce that cognitive load. Let's think about this from a first principles perspective. Have you ever wondered why human beings naturally create categories? Like, why do we organize our computer files into folders? Why do we build houses with separate rooms? Or divide a big company into different departments? We aren't doing it just to be neat.
We do it because of this really profound idea. There's a great quote from Elias in the source text that says, "Chunking is kindness to the nervous system. It tells the mind, you do not have to hold the entire storm. Hold one drop honestly." I mean, wow. We chunk things to give our brains a break. Without structure, complexity just turns into total confusion. Chunking is basically an essential, calming conversation we have with complexity.
Which brings us to a solid definition. Chunking is the art of dividing a large problem into pieces that the mind can actually inspect, name, and test. It's the ultimate tool to protect your attention and build trust in your own work. Think about it. If a chunk is still confusing to you, it really just means it isn't small enough yet. Okay, so how do we actually pull this off? It comes down to a really simple 5-movement rhythm. First, you break the problem apart. Then, you name the pieces in plain, everyday language. Third, you solve just one of those parts at a time. Fourth, you check to make sure that specific part actually works. And finally, you merge the working parts back into a complete path. And the beauty is, this rhythm works whether you're planning a massive family vacation, organizing a messy garage, or creating complex software. That brings us to why functions actually exist. Let's shift this human psychology into a technical concept you've probably heard of, especially in math or programming. Functions. A lot of people hear functions and instantly think of cold, boring mathematical syntax, but they really aren't that at all.
I absolutely love this insight from Rima in the text. She says we use them because reality repeats patterns. Functions exist because the world is literally filled with regular, repeatable transformations. Think about it. Price and quantity determine revenue. A specific set of symptoms leads to a medical diagnosis. If we had to figure out the rules from scratch every single time we faced a situation, our thinking would be incredibly slow and, honestly, pretty fragile.
So instead, we use functions. And a function is simply a machine. It receives something, it does something very specific to it, and it returns a result. That's literally it. It's just organized thinking. It allows us to describe a useful transformation once and then reuse it 1,000 times over without ever having to rethink it.
And really, at its core, a function is a promise. When you create one of these named chunks, you are essentially making a reliable promise within a larger system. Let's look at the anatomy of how this works.
A good chunk has a few key parts: a name, a clear purpose, an input it needs to get started, an action it performs, an output it produces, and of course, the ability for reuse. And what's super fascinating is that you already see this exact structure everywhere in your daily life. Take a restaurant, for example. You don't walk into the kitchen and tell the chef how to chop onions, right? No, you give an input, your order. The kitchen performs the action, and the output, your meal, is returned to your table. That right there, that is function thinking in the real world. Now we hit on something absolutely crucial: the deep power of naming. Before you can automate any process, you have to compress your understanding of it. This is honestly one of the deepest ideas in problem solving, just the immense power of giving things a clear name. Think about our human job titles. Why do we say teacher instead of the person who stands in front of a room and explains concepts so others can learn? Why do we say doctor or driver?
It's because names compress understanding. They turn these massive, complex bundles of responsibility into immediate meaning. Well, the exact same thing applies to building systems or writing code. When we name a function calculate_total or clean_name, we are drastically reducing the mental effort required to understand the whole system.
But there's a catch here. Naming isn't just slapping a nice label on a giant mess. As Dev notes in the source material, a function with no clear boundary becomes a long page wearing a hat. I love that imagery. A named chunk has to be completely honest. It must do exactly what its name promises, with zero secret side jobs. If a function is called calculate_total, it definitely shouldn't also be secretly sending an email in the background. Honest boundaries are what create trust in a system.
So, moving on to inputs, outputs, and flow, how does the information actually travel? How do these honest, trusted chunks interact with each other to solve that giant problem we started with at the beginning?
Every single interaction follows this journey. You have need, work, and result. Or, in other words, input, calculate, and output. A chunk might need information to do its job, kind of like how a coffee machine needs water and beans. That's your input. Then, it applies the specific rule, or the work. And then, crucially, it gives a useful answer back to the rest of the system. It doesn't just keep the answer a secret. It actively returns the result so the next chunk in the chain can use it.
Now, defining this machine is one thing. That's really just drawing the blueprint. Actually using it, that's another thing entirely. In the text, there's a brilliant analogy for this. The definition teaches the job, but the call rings the bell. Defining a chunk teaches the system the rules, but nothing actually happens until that specific chunk is called to action. It just sits patiently until its specific skill is requested. And here is where it all comes together. If you've ever felt intimidated by programming languages or thought they were written in some kind of alien logic, let this explainer shift your perspective. Python, with its def keywords, its parameters, and its return statements, isn't creating new ways of thinking. It is simply a reflection of this profound, universal human principle. It's a language specifically designed to express the way humans already organize thought to avoid overwhelm. We started this journey by looking at a massive, impossible city. And we end by realizing that no one actually builds a city. They build a road, they build a wall, they connect a pipe. Every complex achievement in human history begins as a collection of small, trusted chunks. So the next time you face a mountain of a problem, don't stare at the peak. Ask yourself, what is the very first piece I can carve out, name, and solve? Thanks for exploring this with me. Now take this builder's mindset and go make your mountain small.